friends, welcome to my channel. I hope you are having a good day. Today we are going to solve a recent Leetcode coding problem 1261 find elements in contaminated binary tree. So this is another very popular medium complexity binary tree related coding problem. So we'll look into this problem details today and we'll understand the logic as well as the approach and the solution how to solve this coding problem. If you are new to this channel, please subscribe to our channel now. The subscription is really valuable and important for our channel. It helps and supports this channel, guys. So let's start. Given a binary tree with the following rules, root.value is 0. For any tree node, if tree node.value has a value x, then tree node.left is not equal to null, then tree node.left.value is equal to 2 multiplied by x plus 1. Okay. If tree node.value has a value x and tree node.right is not null, then tree node.right.value is equal to 2 multiplied by x plus 2. Okay. Now the binary tree is contaminated, which means all the tree node values have been set to -1. Implement find element class. Find element tree node root is the constructor. It initializes object with contaminated binary tree and recovers it. Okay. And boolean find in target returns true if target value exists in recovered binary tree. Okay, so this is what we have to implement. Let's take a look at the constant. Says that the tree node dot value is equal to -1 and the height of the binary tree is less than or equal to 20. The total number of nodes is between 1 to 10 raised to 4. Total calls of find method is between 1 to 10 raised to 4 and target should be between 0 to 10 raised to 6 inclusive. Okay, so let's take a look at some examples. This is the first example. So this is the contaminated binary tree, right? -1, -1. If you recover this tree according to the rules they have set, then it should become 0 and this one will be 2. Okay, 0 and 2. Okay, guys. So if you want to find 1, there is no 1 here, right? So you will return false. If you want to find 2, the 2 is there, so you will return true. Okay, I hope you are getting idea of what they are saying. So this is another example. Okay, so here this is the contaminated binary tree. This is the recovered binary tree. So you will see that it starts with 0. So 0, 1, 2, 3, 4, right? So how we created this tree? They have given us the rules. What are the rules? These are the two rules, right? These are the two rules that we have used to get this tree. Okay, once you have the tree, then you are trying to find out 1. So 1 is there, yes, then you will return true, right? 3 is there, yes, then you will return true, and 5 is not there, you will return false. Okay, so essentially what we are trying to do, so we are actually creating a tree structure like this basically according to their rules. So first we'll understand this tree structure. It starts with 0 as the root node, then it is 1, then it is 2. So how we got that one? According to these two rules, guys, these two rules. So left value is 2 multiplied by value plus 1. So 2 multiplied by 0 plus 1 is 1. 2 multiplied by 0 plus 2 is 2, right? Then you do the same thing here, 1 and then 3 and 4. How you got 3? 2 multiplied by 1 plus 1, right? And 2 multiplied by 1 plus 2. Same thing here, 2 multiplied by 2 plus 1 and 2 multiplied by 2 plus 2. Okay, and so on. So you can create a tree like this. This is the way the tree will look like basically if you follow the rules, the two rules that I told you, right, in the example. So this is how the tree will look like essentially, right? So this is what you will create for the contaminated tree. In the beginning they will give you all -1, but this, once you create a tree, it will look like in this structure. Okay, in this structure. So we have seen two examples. This is the third example. You will see that 0, then 2, then 5, and then 11. This is how the tree will look like for this contaminated tree. Okay, and then you can just use a find method. So how you will implement the find method? The find method implementation is pretty straightforward. When you are creating the tree, you will keep the track of the nodes that you have there, the values in a set, right? In a set. So set holds unique elements, so we can easily implement that find method. But how will we implement this tree? So for that we can use a very important technique called as BFS, right? BFS stands for breadth first search or breadth first traversal. It uses queue, correct? It uses queue basically. So this is how it starts, right? So you will first start with 0, right, node, and then you will create a tree structure like this. For example, you remove 0, and for the left node you will calculate 0 multiplied by 2 plus 1 and you add it here, 0 multiplied by 2 plus 2 you add it here, right? Okay, next time what you will do, you will remove that 1, right? You will remove the 1. What you will do again, 1 multiplied by 2 plus 1, so it will give you 3. You add that here in the queue, and 2 multiplied by 1 plus 2, you get 4. You add that 4 here basically, correct? And so on basically, right? You will keep doing it for the rest basically of the. So I'm just explaining you with this example, but essentially you will be doing the same thing for all the examples, correct? Next time you will remove 2, right? You will remove this 2 and you will get the other two values. So what values you will get now? So 2 multiplied by 2 plus 1, 5. So you add 5 in the queue. 2 multiplied by 2 plus 2, you will add 6 into the queue, correct? Like this. So this is the BFS way we will use it to create the tree from the contaminated tree, right? Once we have that, and we will also keep track of the values in a set, right? In a set we will add it so that we can easily find it, right? Finding values in a set is very quick, so that's why we will use set. So I hope you understood the idea of how we will use the BFS to get this tree, right? And then once you have this tree like this, for example, correct, then you can easily implement the class and find method. Okay, so I will directly go to the code now and I'll explain you through the code how we will implement it. So find elements in the class we are implementing. We'll create one hash set here, which is nothing but set implementation. So this is the constructor, right? We'll take a tree node root here. We will initialize this hash set is equal to new hash set. Root's value is 0 and we will apply a BFS on the root of the tree that is given to us, right? This is a contaminated root. Okay guys, this is a contaminated root. So what we will do in the BFS, we will have this root of contaminated tree. We will create a queue which is essentially a linked list of tree nodes, and we will add root into the queue, and this is the BFS starting point basically, right? So this is the BFS starts here basically, right? And while queue is not empty, you will check the size of the queue, correct, and you will start processing the nodes in that level basically. So what is S? S is the number of nodes in that level. So you will start processing all those nodes in this for loop. You will keep polling the tree nodes. So poll will remove it from the queue. You get that node, right? No, n dot val will give you the current value of that node. You will add that value into the set. Now you will apply the two rules that are given here, right? This is the first rule for the left side and this is the second rule for the right side, guys. So we will apply the two rules. So this is the first rule. Okay, so n dot left is not null. It means that n dot left dot value is equal to your parent's value. This val is parent's value multiplied by 2 plus 1. So you are updating your left node's value and you are adding your left node into the queue for further processing, right? This is how BFS works. And this is for the root for the rule 2, right? This is the rule 2 that we are doing. So n dot right is not null. It means that we have to change the value of that node. So n dot right dot val is equal to your parent's val, right? Parent's value multiplied by 2 plus 2, correct? So you updated the right node's value and you are going to add that right node into your queue for further processing through the BFS. Okay, so this way you will keep looping in this while loop and keep processing the nodes and keep a tree, keep up building a tree in this way basically. This is a way you will keep building the tree basically, right? Okay, for the given tree, for the given contaminated tree. Okay, once your tree is done, right, you already have the set of nodes. Now you can find if the target exists or not, right? If the set contains the target, you will return true. If set does not contain the target, you will return false. So where we are populating the set, we are populating the set values here, correct, in the BFS. Okay, so this is it, guys. So this is the way you can solve this coding problem. This is 1261. So now is the time to test our code and make sure this code compiles and runs correctly against the test cases now. So now as you can see here, we are getting correct answer. For the second one again correct answers, and for the third one correct answer here, right? False, false, true. Okay, submit this code now to the Leetcode. Make sure the code gets accepted by the Leetcode, and as you can see on your left side, the code is successfully accepted. It's 33.33% faster on the submissions compared to other submissions. I'm not sure about these numbers keep changing, so we'll try one more time, guys, and again the numbers remain the same. Okay, so this is on Leetcode 1261, find elements in contaminated binary tree, another very important and interesting medium complexity binary tree coding question that we have solved with the help of BFS and a queue and as well as set, right? So I hope you clearly understood the approach that I explained you with these examples, and you understood the Java solution as well. Guys, it takes a lots of creativity, time and efforts to create these images and create these examples. So if you really want to appreciate our efforts that we are taking for you guys here, then please subscribe to our channel now. Also definitely give a like for this video. Also share this video with as many people as possible so they can also watch and learn from this channel how to solve different coding problems, and click on the bell notification icon button so you won't miss any important interesting videos from our channel. On this channel we create content and videos to help others learn more data structures and algorithmic approaches as well as problem solving, Java programming and coding. You will find more than 600 different solved coding problems. Those are very important coding questions asked by big companies in their interviews, such as Amazon, Apple, Microsoft, Yahoo, Google, Meta, and big companies in their interviews. We came up with very important playlists that is very important from interview perspective. The names of those playlists includes graphs, matrices, binary search trees, binary trees, problems solved by using important techniques such as binary search, dynamic programming, recursion, memoization, how to use and apply BFS and DFS on graphs, matrices and trees. The important data structures related playlist we have for you guys include stacks, queues, priority queues, min heap, max heap, arrays, array list, linked list. So everything is here on this channel for you. So don't miss out on those important solved coding problems. You will learn a lot by watching those videos. You will learn how to solve different coding problems, how to approach them, how to write down and implement their solutions. If you are a Java consultant, we also have important videos that discusses frequently asked telephonic interview questions to the Java consultants and how to answer them. So just do a search on our channel, you will find all those important videos here. Definitely give a like, guys, if you found this video helpful, and thanks for watching this video. Have a great day ahead.